Hello, friends. Today we are going to continue our work on constructions, and we are going to work on copying a segment and constructing a triangle. And I'm going to give you a heads up. We are actually going to do 2 days of notes in this one lesson here. We're going to do both day 3 and day 4. So get ready for a really not so wild ride through constructions. So in your notebook, I want you to be on day 3 in your packet, which is page 7. And have your compass out and your ruler out and a pencil, and away we go. So this first one is we're going to copy a segment. Now, one way to copy a segment is just to use your ruler and redraw it. But the thing is, rulers aren't exact. Most rulers only measure down to 1/16 of an inch, whereas with your compass, you can make a lot of variability in there. So what we do to copy a segment construction-wise is we use our compass as a measurement tool. So if you look down at the bottom of the page, it says copy PQ. So the first thing I want you to do, is draw a line that's longer than PQ. So take your ruler, draw a line that's longer than PQ. And then I want you to grab your compass. I will grab mine. Oh, I hate it when it does that. I will grab my compass and bring it down here. And then I'm going to use my compass and open it from P to Q. I'm going to put the pokey part on P, and I'm going to open it down so it's as wide as Q. Okay, so open your compass from P to Q, and I've basically measured PQ with my compass. Then I'm just going to bring my compass down, put the pokey part on the left end point, and draw an arc that hits the line. Just one little arc, enough to show that it hits the line. And now I have copied PQ, because now this is P, and that is Q, and I can ignore the rest of this line. I've copied a segment. So the steps to copying a segment are: step 1, draw a line longer than you need. Step 2, measure the segment you're going to copy with your compass. Step 3, draw an arc from the end point of your new line. That's it. Turn the page, page 8. What if I wanted to construct an equilateral triangle? Well, we're going to use our compass as a measurement tool again, all right? Before that, though, I'm going to do just a sketch. Do not draw anything. I am drawing a sketch. Do not draw what I'm about to do. If I want to make an equilateral triangle here, an equilateral triangle would have to look something like that, right? But the problem is, I don't know if this point up here is right here, or maybe it's a little bit over there, or maybe it's a little bit over there, maybe it's a little bit higher. I don't really know. So we're going to let our compass figure that out for us. All right, so get your compass back out again. So here's my compass. I am going to measure AB with my compass. So I'm going to put the pokey part on A, open the pencil down to B, and then I'm going to draw an arc from B up. So I'm drawing a quarter circle straight up. Then I'm going to come down here with the pokey part. I am not going to change my compass setting. I'm just going to drag the pokey part down to B, and then draw another arc back down to A. And the point where these two things connect, that is going to be point C. And then with your ruler, you're going to draw a segment from A to C and a segment from B to C. And that is now equilateral, because I use that arc to draw a length that's as long as AB, as far up as I could. And then from a different point with the same compass setting, I drew another arc. So where they intersect, I have now guaranteed that this segment is the same length as that one and that one, making it equilateral. All right. So steps for an equilateral triangle: open your compass from endpoint to endpoint, draw one arc, then move your pokey part to the other point, draw another arc, and where they cross is the top of your triangle, and then you just connect the dots. Okay, now I got to be honest here. I have cats. I love my cats. My cats are awesome, especially my black cat, who you've seen, I think, in a video or two already, Pete. But this question makes no sense. So if any of you have cats, feel free to look at this and scoff, because it's ridiculous. Margie has 3 cats. She has heard that cats in a room position themselves at an equal distance from one another, and she wants to test that theory. That's where my problem starts. When my cats are in a room, they are not an equal distance from one another. They are either sitting on top of one another or just messing with the other one by batting its tail. They don't stay far apart. But I digress. So she thinks that they stay the same distance from one another, and she wants to test the theory. She's got a cat. Let's see, Jojo sitting over here on the chair, and Simon is over here on the bed. She wants to know, where is Mac, her calico cat? Okay, so for this question, all we're going to do is say, well, if they're at an equal distance, let's figure out how far away Sammy and Jojo are. Was it Sammy? Or Simon, pardon me, and Jojo are. And then if the other cat is an equal distance away, the other cat would be somewhere along this arc. So I am going to draw an arc from J. Then I'm going to put my pokey part on S and draw another arc. And where those two arcs intersect, that's where Mac, the other cat, is supposedly. Now, this is the only part that makes sense. Of course, Mac is on a bookcase because cats like to be high up. Again, at least mine do. Or just messing with things. There you go. Day 3, done. Remember how I said we're going to do 2 days in one lesson or in one video? We're already done with 1 day. Let's turn the page. We're just going to make more triangles, which is why I'm smashing these 2 days together. The next day, we are going to construct a triangle, except instead of having it have 3 congruent sides, it's going to have 3 not congruent sides. So if I have a triangle where the 3 sides are all different lengths, that's a vocab word you need to remember. That is called a scalene triangle. Triangle with 3 different length sides is called scalene. All right. I want to make a scalene triangle where one side is as long as A, another side is as long as B, and another side is as long as C. All right. So the first thing I'm going to do is I'm going to copy the long side first. So I'm going to go through that process of copying a segment. I'm going to draw a line that's too long. I'm going to grab my compass, and I am going to open my compass to measure how long A is. A is that long. I'm going to bring that compass down without changing it to my line and draw an arc. Okay. So this is now side A. Cool. And if you want, you can scribble out the rest because we don't need it. You don't have to scribble out the rest. I just do so I don't get distracted by it. Now, I want another segment, but only as long as B. So I'm going to grab my compass again. I'm going to come over here and I'm going to measure B. Okay. It's that big. Let's say I want that length side to be on the left of my triangle. Then I'm going to move the pokey part to the left of what's going to become my triangle, and I'm going to draw an arc. Just like the arc I did for an equilateral, okay? But this time the arc doesn't go all the way from end to end. All right, so now I need to figure out, what about C? Well, I'm going to do the same thing. I'm going to come up here. I'm going to measure C. C is about that long. I'm going to bring my pokey part down over here, and I'm going to draw the same arc, but from a different end point. And where those two intersect is going to be the top of my triangle, right there. And then I'm going to use my ruler to connect the end points to that point. This is as long as B was. That is as long as C was. So when you want to make a triangle with a certain specified array of lengths, you just copy one length at a time. First, you copy the base, then you draw an arc for the left-hand side, then draw a different arc for the right-hand side, and where they meet is the top of your triangle. All right, down here, it says create a triangle whose sides match the given lengths. They only gave us 2 lengths. Huh. All right, well, what kind of triangle? What kind of triangle only has 2 different length sides? Well, that means one of the sides has got to be duplicated. A triangle with 2 equal side lengths is called isosceles. So we are going to make an isosceles triangle. And now I didn't tell you which one to use twice. So because I feel like it, I'm going to use the long one twice. So I'm going to use this one 2 times and this one once. All right, let's draw our isosceles triangle. I'm going to draw a line longer than I need. I am going to use my compass to measure A. You know what? As I say that, I'm going to use my compass to measure C, and I'll tell you why. Because if this is isosceles, I usually like the non-congruent side to be on the bottom. So I'm going to use this to measure B here, to make B the bottom this time. All right, so if I want to make B the bottom, I'm going to draw this little arc right here. And so now this is as long as B, and I don't need the rest of that. Now I'm going to come back up and measure A. And because I want A to be both the left side and the right side, I'm going to draw an arc from each end point of B. So I'm going to come down here, draw an arc up from that left end point, and then from the right end point, okay? Notice I went from the left end point of B to the right end point of B. I didn't go all the way to the right side or anything. I'm going to draw another arc, and where those two arcs intersect is going to be the top of my triangle. So there's the top of my triangle, the vertex. Connect the left-hand side to the vertex. Connect the right-hand side to the vertex. And these are each A units long. All right, what's next here? Constructing a hexagon. All right, so we did triangles. Now we want to construct a hexagon, but not just any hexagon. I want to construct a regular hexagon. All right, so let's talk about some vocab here. What's regular mean? Well, the word regular means if you have a polygon, a triangle, a quadrilateral, pentagon, hexagon, octagon, all that stuff, if you want a regular one of those, it means it's a polygon with all sides congruent and all angles congruent. Okay, like a regular octagon would be a stop sign because all the side lengths of that stop sign are going to be the same. And if I said in your head, hey, picture a hexagon. Well, a hexagon has 6 sides. Oh, yeah, it's the honeycomb thing. That's a regular hexagon. Okay, so if I want to construct a regular hexagon, let's do that together. Now it says watch the video. We don't need to do that because you're watching me right now. But if you forget how to do this, feel free to scan that QR code. If I want to construct a regular hexagon, I'm going to take my compass. I'm going to open it up a little bit. Doesn't matter how much, just open it enough that it will fit in this white space. And I'm going to draw an arc. Mrs. Vibber, that's a circle. That is not a hexagon. I know it's not a hexagon. We're getting there. How many sides does a hexagon have? 6. We are now going to construct an inscribed hexagon by taking this circle, not changing the compass setting. Okay, so I'm not going to stretch it open anymore. I am going to take my pokey part and move it off the center and put it on the edge of the hexagon. And then I am going to just draw 6 arcs. Arc number 1. Then I'm going to pick up my pokey part, put it on that intersection point, draw another arc. Pick up my pokey part, put it on the next intersection, draw an arc. Okay, I'm down 3 to go. Pokey part on the intersection, draw an arc. Pokey part on the intersection, draw an arc. I got 5. Pokey part on the intersection, draw an arc. All right. Those 6 intersection points are going to be the vertices of my hexagon. So I'm going to put a dot at each intersection point. And then with a ruler, you're literally just going to connect the dots. So I'm going to come over here and go dot to dot, dot to dot, dot to dot, dot to da, dot to da, dot to da. And now I have a regular hexagon. So if you want to construct a hexagon, you draw a circle, you keep your compass the same setting, and then you draw 6 arcs around the outside of that circle that intersect it, and then just connect the dots to make an inscribed hexagon. Another vocab word, inscribed. An inscribed hexagon is one where each vertex vertex is on the edge of the circle. All right, last piece here. If I come down, how could you use the regular hexagon construction to make an inscribed equilateral triangle? Well, a hexagon has 6 sides or 6 sides. And if I want a triangle, I only need 3. And if I want to get 3 out of 6, I just only connect half of the dots. So instead of connecting 6 dots, I'm just going to connect every other one. So I'm going to do this blue. I'm going to start with this point, and then I am going to, hang on, where'd it go? Connect from this point to that one. Skip a dot to that one. Skip a dot to that one. Now I have an equilateral triangle instead of a hexagon. Okay, I am done with this video. That was day 3 and day 4. Your task now is to go into your homework packet and try to repeat these constructions. All right, so good luck with that. Reach out if you have any questions, and I will see you again soon. Have a good day, everyone.